get started at the do now. This is T. T for what?
Temperature.
Temperature, and this is let's say R. R for what?
Resistance.
R for resistance. Temperature measured in Kelvin or
Fahrenheit.
Celsius, and resistance measured in
Ohms.
ohms. Very good. Now I'm gonna have two graphs. One is blue and one is red. So this is blue.
Can we work together?
And this is
Can we?
red. Okay. This is not drawn to the scale, but I'm gonna try again.
So is that for mercury, niobium, silver, aluminum?
All right. No.
Superconductor?
Okay. What are the difference between? So I'm gonna give you a little bit clue. Right. This one is the critical temperature. This name is critical temps.
So what is the...
All right. The question is, what are the difference between blue graph and the red graph?
Based on what I know and what the graph shows me, I think it's a superconductor.
Which one is superconductor?
The red.
Blue one.
The red.
I'm just guessing. I
It's
think
a
it's blue.
Okay, so
I
you
think it's red.
raise hand for blue.
I think it's blue.
Raise hand for red. Okay. All right. So the difference between blue and the red is Isaac is right. So as the temperature decreases, what happens?
It loses its
The
resistance
resistance also.
Decreases.
As the temperature decreases, resistance also
Decreases.
decreases. However, the blue one will never get to the
Zero.
zero, but the red one will get to the zero if it reaches the critical temperature, and the critical temperature is
4.2 Kelvin.
4.2
Negative
Kelvin.
181 Celsius.
No.
No, negative 270.
269.
274.
269.
274.
We'll
For
check.
mercury.
We'll check. It's actually 4.2 Kelvin. I'm pretty sure is negative 269 Celsius. But of course, my memory may not functioning well. We always can Google it and check it. But this is true for what? Which atom?
Mercury.
How do you write mercury?
Hg.
So who?
And we've been discovering new things like that yttrium barium oxide thing
That's right.
that has a critical temp of 96 Kelvin.
Who discovered
And I
that?
think,
Who discovered that if you take a mercury, and what you need to do with the mercury?
Cool it down.
Cool it down by what?
Liquid nitrogen.
Liquid nitrogen. If
You can use any cooling method, but liquid nitrogen is the most effective.
Okay, so you take mercury, you take a chunk of mercury and cool it down by liquid nitrogen. What
Be very careful with that.
then add. Okay, so this is where the
So keep a thermometer in
this
there
is hold on.
until it says negative 274.
This is where the mercury is, right?
Yeah.
Yeah.
At high temperature, right?
Yeah.
You put it inside the liquid nitrogen. It's gonna come to
Critical temp.
temperature which is 4.2 Kelvin,
Yeah.
and it's gonna drop to
Zero resistance.
zero resistance, and what happened? Zero resistance means what?
Superconductor.
It turns to superconductor. So mercury turns to superconductor at 4.2 Kelvin, which is negative 270 degree Celsius. Discovered by who?
Is it some guy like HK Onion?
8K honest.
S.K. Honest. So H.K. Honest discovered what?
The superconductor.
Superconductor in 1911, and he won the Nobel Prize for that, right?
Yeah.
Now, what good is the superconductor?
It has no resistance, so charges can get through it faster. They don't have to break through the atoms. They can just zoom through the...
That's right. So
wire.
there is no atoms that disturb or that
These look
blocks. There is no atoms that blocks the what?
Current.
The path of electron that carries the charges, creating electric current inside the electric circuit.
And this makes everything from floating trains to particle accelerators.
That's
Really?
right. Now, can we create the superconductor in high temperature?
No.
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 But we could discover materials there.
Is it possible? What is the room temperature right now? Room temperature is about
70?
about
25
20
degrees
20
Celsius.
degrees Celsius.
25 degrees Celsius is like the standard for room temperature.
Okay. At the room temperature, if you can create the copper, for example, to superconductor, then we'll be able to save what? Lots of power.
Yeah.
So
So why don't we use
HK
superconductors?
Honest experimented that the mercury, he created a ring by the mercury, right?
Yeah.
And the current in the ring,
Oh, smooth. No bumps. No
the
nothing.
current in the ring
Float forever.
float forever without what?
Stopping.
Without any
Or
bumps.
slowing.
Without stopping.
Without losing
Any energy.
any energy.
So why don't we use superconductors everywhere? Is it too expensive?
Yeah.
Liquid nitrogen is pretty expensive.
And is it dangerous?
Liquid nitrogen you can touch.
I mean,
But
but
it is-
it's pretty
it's pretty
dangerous.
expensive.
It's pretty dangerous. They need like protective gloves to wear to even like.
So now let's see the man. Now,
And I don't know why it's called liquid and when it's a gas.
okay, let's see the map. So today and tomorrow. Okay, so today you have a flashlight. And tomorrow you have the same flashlight. Is that okay?
Yeah.
And the flashlight voltage, today voltage is 1.5 volts. 1.5 volt. Okay? And then the current is 300 milliamps. 300 milliamps.
Okay.
Now we want to find
Huh?
we want to find the resistance. We want to find the resistance today. And then tomorrow, do you think that voltage will drop?
Yes.
Why voltage will drop?
Because the flashlights are not made of superconductor, definitely.
And
So
do you
there
think
will
that
definitely a little bump, so maybe it would change to like maybe 1.3.
okay, so let's say 1.2 here. Tomorrow's voltage is 1.2 because voltage drops, right?
Yeah.
If the voltage drops, you think current will be 300 milliamps?
It will also drop?
Because it's not superconductor, right?
No.
The current drop as well. And we're gonna have to find out what is the current. But let's find the first resistance. What is the formula for the resistance? Resistance is
V over I.
VIR.
Wait, but excuse me, Professor. I mean instructors.
Yes.
So we have volts, not millivolts. So then we convert milliamps to amps.
Oh, that's right. Milliamps.
Oh my god.
So milliamps is so current is
1 milliamp is 1 over 1,000 amps. So 300 over 1,000 is 0.3.
0.3 what?
Amps.
Amps. Very good. That's a good point.
So 1.5 over 0.3 is just like 15 over 3. So that's
So
just 5.
5. 5 ohms, right?
Yeah, 5 over.
5 ohms. Okay. Now what is it? 5 ohms, right?
Yeah.
So R is 5 ohms. Now what do we need to
Oh.
find?
Current.
Current. So current is what?
V over R.
Yeah, okay.
V over R and V is how much?
So 1.2 over 5.
1.
So 22.4.
R is 5.
0.24.
0.24 amps. But that's not it. So 0.24 amps
Because
times.
it's 1.2 over 10 is 0.12.
So we need milliamps, right?
Yeah.
And amps.
So we need
So-
to multiply it
one-
by 1,000.
That's right. So we need milliamps on the top, right?
Yeah.
So 1 amps is how many milliamps?
1,000.
So we have 240.
240.
1 milliamp is 1 over 1,000 amps. So we just boom, 240 milliamps.
So we started with how many milliamps?
300
300.
And we end with how many milliamps?
240.
So what is the drop of voltage?
60 million.
Drop of voltage. Voltage drops is how much?
0.3 volts.
0.3 voltage drops, right?
Uh-huh.
And current drops how much?
60 amps.
60 milliamps. So we're gonna call it what? The voltage is proportional to
Voltage is proportional.
Current.
current.
Oh! So, this decreased by 60,000, or 600 of an amp. And that decreased by 0.3 volts. So 0.3 of a volt. So I'm seeing some proportionality here between the two.
Alright, so we're gonna end here, right?